Hello and welcome back. This is Chapter 2. The most important service in Amazon Web Services is probably Amazon EC2. It stands for Elastic Compute Cloud, and it's a service that allows us to spin up virtual private servers really easily. In this chapter, we'll do just that, and we'll get our Java application running on that server. There's quite a lot of work to do, so this video will be a full hour, and we'll be looking at AWS regions, how to set up billing alarms, how to start a server and to install our software on it, such as Tomcat, and security groups. So it will be a long chapter. Of course, you can always pause and take a break, but please don't abandon the chapter in the middle and never come back. If you leave your server running, eventually you will be liable for charges. So at the end of the chapter, we'll stop the server so that we don't incur future charges. So where to start? Well, you will need to be on the aws.amazon.com webpage, and then follow the link either to sign into the console or through my account. You can go through AWS Management Console. And from there, the obvious place to start is following the EC2 link. And this is the EC2 dashboard. And I think the most important thing is that this is going to tell us how many instances we currently have running. Of course, you'll be expecting that to be 0. One thing I need to mention before we go any further is that the Amazon Web Services consists of a number of data centers that are distributed around the world. They call these different data centers the regions of AWS. When we launch one of our servers, we can choose which region we would like that server to be running. In other words, we can choose which data center we want that server to be hosted in. What we're being given on this dashboard is the details of all of the running instances that we have in a particular data center. And it's telling us so right here. It's saying that these are the EC2 resources we have in the US West Oregon region. Now, you might not be seeing US West Oregon here because you might have been given a different default region. But you can switch between the regions by following the link here on the top right. If we drop that down, you can see that at the time of this recording, there may be more for you by the time you watch this video. There are 9 different regions spread around the world. So the main idea behind this, of course, is that if you know your customers are located in a particular part of the world, then it makes sense to host your instance in a region that's close to your customers. So, for example, if you know that many of your customers are going to be in Western Europe or Great Britain, then it would make sense to have your virtual private server in the EU Ireland region. There are other reasons for choosing a particular region. For instance, if you have regulatory requirements, that means you have to have your servers in a particular country, then that might be another reason for choosing a particular region. For this course, it doesn't really matter which of the regions you pick. I'm going to go for EU Ireland simply because that's close to where I'm recording this course. But the important thing about the regions is you will need to remember when you come onto this dashboard to switch your region to the correct one. I've sometimes had it where I look on this page and think, what's happened to all of my running instances? And of course, I'm just looking at the wrong region. So feel free to choose any of those regions. Well, really, a lot of this course is just going to be a step-by-step point and click exercise. In order to launch our first server, all we have to do is click the Launch Instance button, and we're going to be following a wizard. Now, the first step in the wizard is to choose what's called the Amazon Machine image. The Amazon Machine image is a snapshot of a virtual machine. You can think of it as a combination of the operating system and a set of default installed applications. You have a lot of Amazon Machine instances to choose from. For instance, if you need for some reason to run SUSE Linux, then you could choose a SUSE Linux AMI. There's an Ubuntu one there and a Red Hat version. Going a little further down, there are machine images for Windows-based servers as well. Now, that's going to be well beyond the scope of this course because we're not installing on Windows, but you could do so if you needed to. I think the Windows images tend to be a little more expensive to run. Now, really, you could go for any of these Linux-based installations, but the one I'm going to go for is the Amazon Linux AMI. To be honest, I don't really have a particular good reason for using it, other than it's the image that we use to start our servers at Virtual Pair Programmers, and therefore I have a little experience of using these AMIs. But the other reason is it's quite easy to get up and running with this AMI because, as indicated here, it already includes tools such as Python, Ruby, Perl, and most importantly, Java. If you're interested, this Amazon Linux AMI is built and maintained by Amazon themselves, and it was originally based on Red Hat Enterprise Linux. So if you're a Linux user and you're familiar with Red Hat or CentOS or any other distribution based on Red Hat, then you're probably going to be most comfortable choosing the Amazon Linux. If, however, you are an expert on using, for example, SUSE Linux, then you might want to use one of the other AMIs. Now, before I go any further, I have to say this is a difficulty of this course. This course is not a Linux system administration course, but of course we are going to have to do some Linux operations. So my approach for this course is going to be to assume that you know nothing about Linux, and I'll explain every command that I'm going to use along the way. However, I do realise that most of you, or many of you watching this video, will be familiar with some Linux, so I might be patronising you at times and telling you things you already know. So do forgive me for that, but I would hate to lose somebody just because of some boring Linux commands. I'm going to select this AMI, and if you're new to AWS, then I suggest you do the same. Now for a very important decision. We need to decide what instance type we want. And that's really saying how much resources do we want to put behind this virtual machine. And you can think of all of these options as just being different hardware configurations. So for example, if I were to select this one here, I will be asking for a virtual machine which has 2 CPUs. It's actually virtual CPUs, but you can just think of that as 2 CPUs, 8 gig of RAM, and it has a moderate network performance. We can go to some absolutely gigantic configurations. Here's a machine with 40 CPUs and 160 gigabytes of RAM. And you probably won't be surprised to find out that the bigger the computer, the more expensive the costs are going to be. There's a page at the URL you can see here, which will give you a guide to the pricing. The one I mentioned here with 40 virtual CPUs, the name of that configuration is M4.10x large. And if we find that on the chart here, it's telling us that that machine is going to cost $2.52 per hour to run. So a pretty expensive machine for some pretty seriously heavy requirements. By the way, I should have mentioned that the charges may be different in different regions. We're currently seeing the default region here, which is the US East region in North Virginia. If I switch this for Ireland, then the costs did indeed change. It's slightly more expensive in the Ireland region. We're looking there at $2.78 per hour. There is quite a long list then of available instance types, but you can always tell by the name of the instance type what type of hardware you're going to be getting. There's a category which they call the general purpose configurations, and the names of those all start with a T or an M. There's a separate page at the URL here which gives you a full list of these instance types. The ones beginning with T are what they call burstable performance instances. And they're designed as being relatively cheap computers to rent. And they have quite a low baseline performance, but they can, for very short periods of time, give you a little more CPU power. So as described here, these instances are a good choice where your workloads are not going to be using a lot of CPU very often, but occasionally you might need a sudden burst. So they think that web services, developer environments, and small databases would be a good use for the T series of instances. The number, by the way, as in T2, that's just the generation number. And every time they upgrade their data centers with new hardware, they'll increment the number here. So by the time you watch this video, they may well be onto the T3 or T4 series of hardware, but it means the same thing. It's a burstable instance. The M series is just a general purpose kind of balanced solution, which has reasonable CPU power, reasonable network, and reasonable memory resources. Notice that these at the time of the recording are now on the 4th generation. But there are some more. The C series are compute optimized. Basically, they just have far more powerful CPUs. You might be using a C4 instance if you're doing constant heavy number crunching. Maybe if you're planning to use Hadoop or something like that, then a C instance might be for you. The R series is a memory optimized series. They have quite a low cost per gigabyte of RAM. And there's a very interesting G series. Now, these have graphics cards attached to them. At the time of recording in the G2 series, they're high-performance NVIDIA GPUs. So, of course, you could use this for operations such as transcoding videos. And interestingly, they mention a use case here of 3D application streaming, which is a possible new wave in computing where applications such as a graphics-intensive photo processing system, okay, I'll say it's something like Photoshop. In future, you might be able to, instead of buying Photoshop and running it on your own desktop computer at home, you would be able to run Photoshop remotely on these servers, and therefore you could run even the most intense 3D graphics processing packages on the lowest level hardware on the client side. So that's possible for the future. Some newer instance types that haven't been available that long, there's the I series for high input-output requirements. So as mentioned there, databases would be a possible use for those. And we have the D series for dense storage. And this is for when you need very high levels of hard disk space. So there's a matrix there summarizing the different types, and here's a chart with the pricing. So if you wanted an I/O intensive instance with 32 virtual CPUs in the island region, you would be looking at $7.50 per hour, which I think at the time of this recording is the most expensive instance type. What we want for this course is the cheapest possible option that we can possibly get by with. And it turns out that the T2 Micro, don't forget, as I say, by the time you watch this video, the 2 might be a higher number. But essentially, the lowest, the smallest possible machine in the list is currently only costing around, actually about 1.5 cents per hour. So that's pretty cheap. But if you have only just signed up for your AWS account, then you will be eligible to what they call the free tier. And I've gone back now to the AWS console. You can see on the first line here, the T2 Micro is free tier eligible. Now, as I say, this is only applicable for the first 12 months after you've signed up for AWS, but you will get 750 hours of free time. Now, if you do the maths, 750 hours per month is enough to run that server constantly for the entire year without incurring any costs. However, I've got to warn you, the free tier, the 750 hours is your total number of hours that you've run across all of your instances. So if you fire up 2 of these T2 micros, then you're only going to get the first half of the month for free. So you've got to be very careful when you're doing this course, if you don't want to incur charges, not to accidentally start up more than one instance. If for any reason you're not eligible for the free tier, perhaps you signed up for AWS a year or more ago, then you are going to have to incur some costs to run this course. But as you've seen, the costs are pretty minimal, and you will be able to shut down your server as soon as you've finished working with it. So you might only need to run your server for maybe 2 or 3 hours at a time. So let's go for the T2 micro tier then. You probably wouldn't be able to run a production workload on T2 micro. It should be enough for the course though. So we'll click next, and really we can go with all of the defaults on this page. We'll go to add storage. The default amount of disk space on this instance is 8 gigabytes. And if you drop down the volume type, you can choose between SSD drives or magnetic drives. So we'll stick with the default of general purpose SSD. And take note here, at the time of recording, we're eligible for up to 30 gigabytes free of storage. So we could change the 8 there if we wanted to. I'm not going to though. We'll click next. We're now able to set up a tag. Now, a tag is just a key value pair, and you can do anything you want with these tags, and you can create up to 10 of these tags. The most common thing you'll want to do here is give a name to your server. This is just my test server, so I'm going to give a value of test server. But you could carry on adding tags now to capture any useful information that you want for this server. Now we'll click next to configure the security group. Now this is going to be an important thing that we'll need to think about. You can think of the security group as being a set of firewall rules. So this will allow us to determine what traffic we're going to allow on each of the different ports on this server. If we click on create new security group, we get the default firewall rules, which is that we are going to allow traffic on port 22 from any IP address. Now, I don't know if you know, but port 22 is the SSH protocol, and that's what we're going to be using to connect to the server. So we're almost certain to need SSH open on this server. What we could do if we wanted to be hyper secure is we could work out what the IP address of the computer that we're running here locally is, and we could specify that only our computer is able to connect to this server. For this course, I'm going to leave the sources anywhere, but you might decide to be more strict. We are going to need to add more rules later on, but we can do that later. So I suggest that we just click on Review and Launch. So on this confirmation page, we are getting a warning that we are open to the world. So it means that anybody can try to connect to our server through port 22. Now, I'm fine about that for this test server, but as I say, if you were deploying a real server, I would definitely consider having a whitelist of only known IP addresses. But the rest of it is just a confirmation of what we've already specified, so we can now finally click the launch button, and we now have to go through the process of setting up a key pair. For security reasons, AWS has decided not to allow direct logging on to your servers using a username and password. It simply will not be possible. The only way that you can connect to your instance is by supplying a key pair file. Now, a key pair file is a combination of a public key and a private key. You might be familiar with working with key pairs in other scenarios, such as when you're working with SSL or TLS. But if you're not, you can just think of this as being the file that we need to access our server. So this is really important. We're going to create a file here by dropping down this list and selecting Create a new key pair. And then for the key pair name, we can specify any file name that we like. So I'm going to call this my key pair. You could call it anything you like. And then we download the key pair file, which is now downloaded to my local computer as a normal file. Now, as we're warned here, you cannot do anything without this key pair file. You do not get the opportunity to download it again. So you need to store this file in a private but accessible location. And by accessible, it means accessible to you, the system administrator. So we would typically store that file in some kind of secure keychain or some kind of secure storage system somewhere. Certainly don't go putting that on any public network share or uploading it to a public FTP server or anything like that. It needs to be somewhere secure for you. Let me reiterate, you will not get the opportunity to download this file ever again. If you lose this file, you will have to destroy the server and start again. So heed that warning, keep this file safe for the rest of the course, but now we can launch our instance. So we've been directed to this holding page now, but if I, as quickly as possible, go back to the cube here, will take you back to all of the services, and then go to the EC2 icon here. I can now see that I have one running instance. And if I click through to that, it does say that the instance is running, but just going a little further to the right here, it is also telling me that the instance is still initializing. And you will find it is going to take some time before you're able to connect to this server. So don't be in too much of a hurry to connect to your server. While we're waiting for this server to complete initializing, I think it might be worth setting up a billing alarm. A billing alarm is useful because this will send us an alert, for instance, an email with a warning if the costs that we're running up have exceeded a particular threshold value. And it's worth doing that because if you were to make a mistake here, let's say in the previous steps you've accidentally started up one of those really expensive instances, then you're going to be running up bills and you can't hold me responsible for those bills. So I recommend you go to your username here at the top, select billing and cost management, and it's worth checking this page every day anyway just to see what your spend has been. Now you should be seeing 0 here. I ran up 5 cents of charges last month and 4 cents this month just doing the rehearsals for this course. But actually all of those costs were incurred on Amazon S3. I used S3 to transfer a few files around that I was using to develop the course. So none of my costs were on EC2, so I'm expecting that you won't be running up any costs either. But if we go down on this page, there's an alerts and notifications window. And if we set the link to the create your first billing alarm. Now, even the billing alarms cost money, but we get 10 free alarms and up to 1,000 free email notifications as part of the free tier. So again, we shouldn't have to worry about the costs of this, but we can create an alarm. And so I suggest that you do something like when your total AWS charges for the month exceed, let's say $1, send a notification to, and you can type your email address in there. And then just create an alarm. Now, for security reasons, it will expect you to confirm that email address. So check your inbox. You should have an email from AWS. And if you follow the link in that email, it will confirm the address. Okay, so I did that off camera. That's the alarm set up. In a short while, this one will change from insufficient data to something like OK, unless we go over the threshold, and then it will switch to alarm and we will get an email. So while we were doing that, we can now go back to the EC2 console. And actually, just while I was setting up that billing alarm, I flicked across to North Virginia, so I'm not seeing a running instance, and that's because my instance is in EU Ireland. So there's our running instance, and before it said initializing, now it's saying that 2 of 2 checks have passed, and it does look like now our instance is running. The next job then is we will need to connect to this server. If you're on Mac or Linux as your desktop operating system, then you can very easily connect to your instance from the command line. If you're on Windows, you will need to install some software to do this. There are a few different options. You could use a tool called PuTTY, which is a very common one to use, but personally, I prefer to do everything through Cygwin. You may be familiar with Cygwin, but if you haven't already installed Cygwin, then I strongly recommend it. This will give you essentially a new command prompt, which is much more like a terminal that you would have on Linux. And you can install a full suite of Linux-based tools. And the main tool that we'll need for this course is the client called SSH, which enables you to create a secure shell connection with your server. So if you don't already have this, then you can find it at cygwin.com. Follow the link to install, and then you'll need to download either the 32-bit version or the 64-bit version. When you run this setup, you will want to select Install from Internet. The next page is asking where we're going to install to. I'll go with the default. Local package directory, again, I'll go for the default. If you're working behind a proxy, then you will need to configure that here, but I'm on a direct connection. And then you'll be presented with a list of mirrors. I usually just go with the one that's been selected by default, but if you have any problems installing, if it's very slow, for example, then you might want to come back here and choose a mirror that's close to you. But now for the important bit, there are thousands of packages available for Cygwin, and the default installation just gives you a base installation with the very basic tools that you might need. And what we need to do is to check that SSH is definitely going to be installed. So enter SSH into the search box here, and then drop down the entry called net, and you're looking for the entry for OpenSSH. And what you don't want to see on this line here is the word skip. If it says skip, it's not going to be installed. Now it's telling me keep purely because I've actually already installed Cygwin, so it's just saying, yep, I'm going to keep this version of Cygwin. But if you're seeing the word skip there, you'll need to click until you see when the version number comes up that says it's going to install this particular version of Cygwin. If in the future you want to install further packages, you just need to run the installer again, search for the packages that you want, and do the same process. So make sure that SSH is going to be installed. You can now click Next, and typically it does take a long time to download all of the packages. Once you're done, you might want to create an icon on your desktop, and the icon will look something like this. And when you click on that, you should get a terminal window, and if I type SSH, you should get a usage warning rather than something like no such command. So if you're a Mac and Linux user, then you can rejoin me now. All you need to do is start your standard terminal window, and you should find that SSH is installed. So if you got this far, you're now ready to attempt to connect to your running server. The first thing you will need to do is to navigate into the directory where you're stored your .pem file. For those of you working on Cygwin, there's a slight complexity here in that the file system that you're seeing here doesn't quite match the file system that you have on Windows. There's no concept in this shell of a C drive, for example. If I do a pwd to print my working directory, you can see that we're seeing a kind of a Linux or Unix-like file system going on here. What they've done is they've emulated a Linux system by mounting your C drive and any other hard drives that you have to a mount point. And that mount point, we can change directory into it with cd / and then sig drive. And if you do an ls there, you will find a list of all of the hard drives that you have on your system. I've got 3. So I can CD now onto the C drive, and I am now indeed seeing the full contents of my C drive. Now I could move the .pem file around, but I downloaded it through my browser, so it will be in my downloads directory. So that will be under the users folder, and note that Cygwin is case sensitive, just like Linux. And then your username, which on this computer is, for me, work, and then you'll find your downloads folder. But as I say, you could have moved that .pem file to anywhere that you like. But there is the PEM file that we created earlier. So back into the Amazon EC2 console. And of course, to connect to this server, we're going to need to know its public IP address. There are a couple of ways you can find that out. First of all, if you select the server by clicking on the radio button here, in the description box down here, you will see that there is a public IP address currently associated with my instance. Of course, the IP address that you're seeing will be different to the one that I have here. So you could use that. Another way is if you, again, select the server and then click on the connect button here, it will give you full instructions on how to connect to your instance. So it's telling us that we need to open an SSH client. Well, we have one of those ready. We've got our PEM file, but now a really important step. Even if we're on Windows, this applies. The key must not be publicly visible for SSH to work. So we're going to need to change its access rights, and we can just use the command exactly as described here, chmod 400 mykeypair.pem. That just removes read, write, and every other access to everybody other than ourselves. And then it's even giving us the command we need for SSH. It's going to be SSH-I followed by the PEM file. Then it's the username and the IP address. Now for the Amazon AMI that we're using, the default user is EC2-user. If you've used a different Amazon machine instance such as Ubuntu, then the username here will be different. Now, I just want to prove that the chmod really is required here. I'm going to try doing the SSH, but without doing the chmod. So it will be SSH-I mykeypair.pem EC2 user. For me, 52.17.90.211. If this is the first time you're connecting to this instance, then we will be getting a warning that the authenticity can't be established. That's not a problem. We just say yes to this, and it will store the fingerprint of this server in a local file. So in other words, it will remember this server. And as you can see there, we have a warning, unprotected private key file, permission denied, bad permissions. So as advised, we need a chmod 400 for the mykeypair.pem. And if we try again, we've now reached a really good point, because all being well, I hope you're seeing a similar thing to me. You're getting a kind of a welcome message to this Amazon Linux AMI, and you might be seeing that some packages are needed for security. And what will have happened is, since the Amazon machine instance was built, there are some of the packages that are installed on this computer will have had some security updates released, and they recommend that we apply those updates. Now, it doesn't really matter for the course, I don't think, whether we have those updates or not, but I think just to be clean, we probably should take their advice. So if you're seeing this message, then I advise you run sudo yum update. Of course, if you're not seeing this message, then that just means that they've recreated this AMI quite recently and there are no packages needing updated. In case you're not familiar with what yum is, this stands for yet another update manager, and it's the package manager for this particular flavor of Linux. So we can use the yum command to install programs and update programs and so on. We're going to be using that quite a bit over the next few moments. So sudo yum update, we should get a confirmation of how much is going to be downloaded. Is this okay? Yes. And that might take a short while to install. We're expecting eventually a message to say complete. The first big job that we need to do on this server is we need to get Tomcat installed. Now that's not too difficult to do on an Amazon machine instance because you should find that Java is already installed. If we type which Java, you will find that it's giving you a file location. So that suggests that Java is there. And if I do java-version, now this may be different for you because they do update the Amazon machine instance over time, but I'm seeing that we have Java version 1.7 installed on this computer. I've just switched to Eclipse because I have a slight worry at this stage and I don't want you to get into problems here. But when I built that build file earlier on in the course, I was using, and we can see here from the reference libraries, I was using Java 1.8. And what that means, of course, is if we try to run them here on the server, which is currently using 1.7, we will get an immediate exception. Because, of course, you can't run newer versions of Java on older versions of Java. So obviously, there's several ways we can get around this problem. An easy one would be to simply go back to our development environment and install a corresponding JDK. So we could put 1.7 into here and recompile everything. That's fine if you want to do that, but I've decided to do it the other way around. I'm going to upgrade this server so that it matches the version of my local development. So in other words, I'm going to install Java 8. If I do the command sudo yum, again that's the update manager, I can add the parameters list installed, and that will give me a list of all of the packages that are installed onto this machine. Well, there are an awful lot of them, so I'll do a clear there and I'll rerun that command, but I'm going to add on to the end the pipe symbol, the vertical bar, and grep JDK. Now, of course, I'm never sure on these courses how much detail I need to give here because I know that some of you will be experienced with Linux and some of you won't. But just very briefly, in case you're not, the pipe will take the output from this command and it will use that output as an input for the next command. And the grep command is a search. So it will search for all packages containing the letters JDK. And as you can see here, the package is called java-1.7.0-OpenJDK. So I want to uninstall that. So I do that with sudo yum remove, and then we use the string here. You don't actually need all of it. You can just use enough of it to identify it. So java-1.7.0-OpenJDK should be enough to do a remove. So it's confirming here it's going to remove one package and 5 dependent packages. If I say yes, then that's complete. Now we need to check first that Java 8 is actually available. And I can do that with sudo yum. Very similar to before, I'm going to do list, but instead of installed, I'm going to say available. And once again, I will need to pipe that into the grep command searching for JDK. And that's usefully giving me a list of available packages. So we have 1.6, 1.7 and 1.8. And by the time you watch this course, you might possibly be using 1.9 or 1.10 or something in your local Eclipse. It might not be available here in the packages. It just depends on whether that version of Java has been built and has been published in the repositories. If it's not available here, then I recommend that you take the simpler path, which is to download the correct version in your local environment. But at the time of this recording, we're okay because I can do a sudo yum install. And again, I just need the front bit, java-1.8.0-openjdk. There are various alternative packages here. This one here is the complete source code. This one here is the Java docs. Here's a version for headless servers. That means there's no console attached, but we just need the basic bare JDK. So we'll say yes. Now, while that's installing, I'll just mention that you might be a bit nervous installing the OpenJDK. For a few years, the OpenJDK was a very kind of incomplete Java development kit and didn't have the full suite of tools that the standard Oracle Java development kit has. That's not really the case today. In fact, the OpenJDK is pretty much identical to the official Oracle JDK. The Oracle JDK just has a few extra additions included. But if for any reason you don't want to run the OpenJDK, you can install the full Oracle JDK, but you can't do that easily using the yum tool. If you wanted to install Oracle JDK, then you would need to go to the Oracle site, you would need to download the package from there and install it manually. It's not that difficult to do, but it's not really worth any extra effort for this course. So once that's complete, we should now be able to do java-version, and wonderful, we have version 1.8. So that's the JDK. We now need to install a web server, and we're going to use Tomcat. And really the process is the same. If I recall the command where I'm listing available packages, but this time I will grep for Tomcat. Again, a long list of them, but the important thing is we can choose between Tomcat 6, Tomcat 7, or Tomcat 8. You probably know that the Tomcat version numbers reflect the version of Java that they're intended to be run upon. So we're going to need Tomcat 8. So sudo yum install Tomcat 8. We'll confirm that this is okay. And hopefully that was as smooth for you as it was for me. So we're certainly not there yet, but it might be worth trying to see if we can see our Tomcat running on the live internet. Go back to the AWS console and remind yourself of the IP address. And remember, you can get that from the connect button on your instance. So I'll copy that to my clipboard. In a new tab, I'm going to try to visit that IP address. Now that's definitely not going to work. And I did a little edit there. It took about 30 seconds before the connection timed out. Well, it wasn't going to work anyway because Tomcat runs on the port by default of 8080 and not the standard port 80. So we could try that as well, but I think you're going to find, and yeah, we're getting a timeout on there as well. So there are a couple of things we need to do, and I don't know if you've spotted it, but the first obvious one is you might remember a little earlier in the course we were asked to configure a security group. And a security group is a set of firewall rules. Now, if we go to the EC2 console and find your server in the table, if we scroll across to the right, the name of the security group, I think, will be a default name that was created when you set up your server. But if we follow the link there, my security group is called Launch Wizard 1. We have a set of inbound and outbound rules. And on the inbound rules, currently, the only port that we have open is port 22. Port 22 is the port for SSH. Without that, then none of this would have worked. Now, of course, we want to open our server to internet traffic, so we want to open up port 80 and, for Tomcat, port 8080. A little later on in the course, we will close port 8080, so if you're worrying about that, don't worry, we will revisit that later. But to do this, we need to edit the rules, and then for type, you can drop the box down and find HTTP. The protocol will be TCP, the port range will be 80, and the source as before, will be anywhere. And we'll add another rule. This one needs to be for port 8080. Now, there isn't an entry for that in the list, so we just select custom TCP rule, protocol TCP, and the port range this time will be 8080 and the source anywhere. So click on save, and that should mean that now our server is open to traffic. But again, going back to the browser, if we refresh the 8080 version, we're still seeing connection refused, but there was a definite difference there that might not be obvious on the video, but it might be more obvious to you. We are getting a much faster refusal. Now, the reason for this refusal is a simple one. We have installed Tomcat, but it isn't running. Now, I made a bit of a mistake here. I don't know if you've spotted it, but I have had to come back and re-edit this part of the video. And it only became obvious to me when I switched across to my SSH client and I tried to start Tomcat. Well, I couldn't issue any commands at all, and eventually I got a connection reset. It's a stupid mistake. You may have spotted it. In editing these firewall rules, I've gone and removed my rule for port 22. So the firewall came up and I was prevented access. So that wasn't very sensible. I'm going to blame the bad user interface here that Amazon provided, and I'm sticking to that story. So I will, of course, need to edit the rules again. And of course, what I did was I modified the existing SSH entry rather than adding a new entry first. So if you did the same, I'm sorry about that. Easily fixed though, we can add a rule for SSH. That's port 22. And I'm going to say anywhere again, just for simplicity. But if you want to be tight here, you would specify your local IP address that you have at home. So let's save those rules, and I should now be able to reconnect to my server. And I can. So the point is, I now need to start Tomcat. And the command to do that on this flavor of Linux, it's very different on different flavors. On this flavor of Linux, we're looking for sudo service followed by the name of the service. Now that's going to be Tomcat 8. And then the command start. And you might see an OK message on the console there. If you need to restart Tomcat, then you just use restart there, and you can probably guess that we can use stop as well. One of the problems with starting that service is we don't get any kind of good feedback as to whether things went well or not. Now, checking the logs is a little bit awkward because we need to deal with file permissions. We will do that at some point, I'm sure, but I think the easiest way to see if everything works is just to go back to the browser, and we will refresh the page where we were accessing port 8080. That is really important. And this time, well, this may be different for you, but I am not getting an error this time. I'm just seeing a completely blank page. I think it might be different for you depending on the browser you're seeing, but I'm certainly not seeing a connection refused problem anymore. So what's going on here? Well, it's simply the case that the default Tomcat installation doesn't come shipped with any predefined web applications. So there's simply nothing running on our Tomcat instance. And usually the job now would be to simply install our WAR file. But I'd kind of like to see the friendly Tomcat welcome page, just to give me a little bit of confidence that we're going down the right route here. That standard Tomcat welcome page that you might be familiar with does not ship as part of the standard installation. But we can install it very simply. If you go back to your SSH client, and we can do a sudo yum install Tomcat 8 web apps. And if we confirm that, this is going to install the friendly welcome page. So once you've installed, we'll refresh. And that feels really good. We are definitely seeing that Tomcat is running, and I hope that's the same for you as well. So we've got a live server running on the internet. The next job is to get our WAR file uploaded to the server. Now, there are lots of ways of doing this, and I would suggest the professional way of doing this would be to install some kind of continuous build tool, such as Jenkins, which you may have heard of. You might be familiar with it. With Jenkins, what would happen is when we run our build here, a tool on the server would detect that we've run a build, and it would automatically deploy that built war file to Tomcat. That's the kind of thing we would want in a production environment. We might well do that on future chapters of this course if there's demand for it, so you know what to do. If that's something you want, send us a message, preferably through our Facebook page, but you can send us a contact message as well, and then we'll know to make that a priority for the future. But for this getting started course, I want to do things in the simplest possible way. And you might know on Tomcat there is a manager app that allows you to upload your WAR file. Only slight problem is, if I click on manager app, I'm getting a 404. And it's for the same reason as before. By default, that manager app is not installed. So again, back to SSH, if we do a sudo yum install tomcat 8-admin-web apps, will install the manager application. So confirm that and all should be well. While I'm here, I don't know if we'll need it, but there is one further web app that's linked from that welcome page. So I've just recalled my install command, and this one is the Tomcat 8-docs-web app. Of course, that's a selection of user guides that you might find useful. And well, no, I have a no package available for that. I think it's because this one is its docs web app singular, whereas admin had several web apps, so that was a plural. So let's try that. Yeah, that's installing this time, so all is well. So we should now be able to refresh this page, and you can see that we're being asked for authentication. We have to log on as a Tomcat manager, which is great, but the problem is we haven't got a username and password defined for this Tomcat instance. I'll cancel that. And actually, helpfully, when you cancel it, it's even giving us information on how to configure a Tomcat manager. And it's telling us that we need to look in the file called conf/tomcatusers.xml. So we need to edit that file then, and you will find the Tomcat installation under the folder /usr/share/tomcat8. You do a directory listing in there, you will see the familiar Tomcat structure. We need to cd into the conf directory, and the file we're looking for is tomcatusers.xml. You can use any of your favorite Linux text editors to do this. Personally, I would like to use VI at this stage, but my editor, Matt Greencroft, has banned me from using VI on our courses, much to my annoyance. Probably, to be fair, the easiest text editor that has been pre-installed on the Amazon machine instance is the Nano text editor. But of course, you can use any editor that you like. So we're editing the tomcatusers.xml file. Now, of course, I forgot we have a permission denied here because we don't have write access to that file. So Control and X will exit the editor. Now, of course, I need to do a sudo nano tomcat users to do this as a super user. So it's an XML file, and you will find that most of this file has been commented out. And these commented out sections are just left as kind of samples and examples for what we need to do. But to run that manager application, we need to have a role defined called manager. And there is actually a line there that does this. There it is, but it's been commented out. So we just need to uncomment that line. Then we need a user that is in that role. So if you go down to the bottom, there is a user called admin with the password of admin with some predefined roles, quite a long list of roles, in fact. And actually, I'd forgotten that this is a new thing since I think Tomcat 8. In the old days, we had just a single role here of manager, and that was all that was needed. But they've split the roles up into lots of separate roles. And I think we need all of these roles to be in this list. And that means, in fact, we need to uncomment out all of these roles above. So just knock out all of the comments. I'm sure there's a quick way of doing this in Nano, but because I don't know Nano and I'd rather be using VI, I'll do it the longhand way. Okay, so all of these are now uncommented. We have a user called admin with a password of admin. Now, in real life, and I recommend you do this now if you're following along, you need a strong password in here because, of course, this server is going to be open to the whole internet. Now, I'm not going to bother here for the course purely because I know in half an hour's time when I've finished recording, I'm destroying this server. So there's no danger of anybody coming along and hacking it or something like that. But for you, you really do want a good, strong password in there. So once that's done, we can save the file. We do that with Control and O, interestingly, to write out. We need to confirm the file name by pressing Enter, and then Control X to exit the editor. We need to restart Tomcat now, and we'll do that with sudo service tomcat 8 restart. We should be able to go back to the manager URL and refresh it. And I am in. I wasn't asked there for my username and password, which I think is because off camera, when I was setting this up, I did enter my basic credentials. And as with all basic authentication, those credentials are remembered by the browser, and the username and password is being sent in all subsequent requests. So that's why I didn't see a login box there. You may well have been prompted to log in at this point. Okay, well, we now have the Tomcat Web Application Manager, and we are getting very close now. I don't know if you're familiar with this manager app, but it is an easy way of deploying a WAR file. Of course, we could upload the WAR file to our server and put it in the web apps directory, just like you do locally. But we'd have to work out a way of actually transferring the file to the server. As I say, in future sessions, we might use a proper build tool like Jenkins to do this automatically. So what you need to do here is to find the section WAR file to deploy and click on the Choose File button. And navigate to your workspace, and then in the project folder, if you built the WAR file yourself, you will find inside the dist directory the bookstore.war file. So we open that, then click deploy. This will take some time to upload depending on your connection speed. I'm at about 10% now, so this is going to take a while. Now I realize that there is a lot of potential for error here, but I hope that it has gone smoothly for you, as it has for me on this recording. The message here is saying OK, and that means that our web application is now deployed. If we go down this list, we can now see that there's an entry for the bookstore. Well, if we click that link, disappointingly, we have a 404 error. But actually, that's not really a problem. That's just because in this development, we haven't defined a kind of homepage. We haven't got a URL mapping for the / URL. Exactly as we did locally, we need to visit the page called viewallbooks.do, and as usual, this will be case sensitive. And I'll hold my breath. That is absolutely fantastic. We've reached a great position here because we are now serving up our Java web application on a live internet-based server. Of course, there's still a lot more to do. I would like this data to be coming from a live database, and we'll be doing that in the next chapter. I'd like to get rid of the :8080 because, of course, almost no real websites are served from 8080. I would also like to talk in a bit more detail about these IP addresses because at present, those IP addresses are going to constantly change, which would be a real problem in a live deployment. So all of that coming up later on in the course, but for now I think you've earned yourself a break. Just for caution, I would recommend that if you're stopping at this point and maybe you're doing the next chapter tomorrow or maybe in a month's time or whatever, I would recommend you go back to the AWS console, go into the dashboard, find your running instance and select it, select actions, instance state, and stop. Now, the warning is just saying that any data on ephemeral storage, and that really means just the memory in RAM, any of that data will be lost. So, for instance, if you're concerned about Tomcat sessions that are in memory, then they will be lost. It doesn't mean the data on disk. It's absolutely safe to stop the instance, and you can restart it again at any time in the future. And the reason for doing this is that once you've stopped it, you're not going to be incurring any charges. And I'm just worried that, if you leave that running and then abandon this course and you forget the server's even there, even if you're on the free tier, in a year's time, you will start getting bills for that server. So at the end of every chapter, it's worthwhile closing everything that you're using just for safety. But we've reached stage 1. Well done. And I'll see you for the database.